All right, today we are going to finish up section 1.5, solving quadratic equations by finding square roots. One of the characteristics of solving an equation by square roots is that you'll notice there is only an x term. When you look at the rest of the equation, there is nothing with a single x term as there is in standard form. So that is usually a clue that you can solve it by finding square roots. Now, in the beginning of section 5, you learned how to simplify radicals. So unless you are told otherwise, you have to leave your answer in simplified radical form. All right, let's take a look at this. This is 3x squared plus 5 equals 41. Well, again, one thing I noticed that there is just a single x squared. There's only one variable. That's an x squared. There's nothing that can be combined on each side. So at this point, what you want to do, let's go ahead and rewrite the problem as step 1 said. So you're going to go 3x squared plus 5 equals 41. Now normally, just like you would want to solve an equation for x, in this problem we want to solve it for x squared because the opposite of a square is a square root. So if we can get it down to an x squared, then we can just square root each side in order to get the answer. So to do that, we're going to subtract 5 from both sides. So you're going to do minus 5 and minus 5. And the resulting at that point is 3x squared equals 36. Then you're going to divide both sides by 3. And now you have x squared equals 9. All right, now at this point, in order to get just a single x, you have to do the opposite, or just like you undo addition by subtraction or you undo multiplication with division, you undo a square with a square root. So simply by putting this square root here, what that does is that square root cancels that square, leaving you with just an x. But just like always, what you do to one side, you must do to the other. And 9 happens to be a perfect square, so the square root of 9 equals 3. However, ding, 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 look over here. It says, remember, square roots have two answers, one positive and one negative. So whenever you find the square root of a number, it is actually positive or negative 3. And the reason is we're trying to figure out what x squared would equal 9. What number squared would equal, not 3, 9. So you could take a positive 3 and put it in and get 3 squared equals 9, or you could get a negative 3, which is negative 3, and get 9. So both of those solutions would be correct. Okay, let's move on to B here. All right, first step, first thing you want to look at is you want to determine, hey, is there anything other than an x squared term? And the answer to that question is no. So your goal here is to get the x squared by itself. So you need x squared equals something. So we're going to divide by 5. Both sides. So now we're going to have x squared equals 16. Now, in order to eliminate this square, we're going to square root both sides. So this square root cancels this square, and that leaves you with x equals square root of 16. Again, it's a perfect square, so that would just be 4. But remember, it's positive or negative 4. So that would be your final solution. Okay, move over to C. This one's a little bit different. Yes, you have an x squared term. However, this one doesn't have multiplication in it like that one does. So this one, the same situation. Your ultimate goal is to get z squared equals something. So add 7. And what you're going to have is you're going to have z squared equals 36. And then you're going to take the square root of both sides. Square root and square cancel each other. So you're going to get positive or negative 6, and that's your final answer. All right, now if you look at D, it's a little bit different. This one we have multiplication. This one we have a square on an entire set of parentheses. Well, the good news, you guys, is it's not any different. You're still following the procedures. So, and no, you do not need to FOIL this one. Can you? Sure, but it's a whole lot more work. So what you want to do is, let's cover up this right here. You see 3 times x minus 2 squared. This 3 is multiplied by to everything in this problem because it's a distributive property problem. So you could actually go ahead and divide by 3 here. And what that will do is that will cancel, and you will now have x minus 2 all squared equals 40 over 3. Okay? So then when you have x squared equals 40 over 3, now why don't I change it to a decimal? Why? You're going to remember, you need to square root both sides. So you don't want a decimal. There really technically is no such thing as the square root of a decimal. So you want to leave this in fraction form. So this square is on the entire parenthesis. So if I wanted to eliminate the square, I would just take the square root of the entire parenthesis. So this square cancels this square root and leaves me with x minus 2. But then remember, what you do to one side, you have to do to the other. And this takes us back to what you learned at the beginning of 1.5. So at this point, you have the square root of 40 over the square root of 30. And if you recall, you can't have a radical in the denominator. So what you want to go ahead and do is you want to multiply this, get the square root of 3 times the square root of 3. So now what you have is you have x minus 2 equals the square root of 40 times 3, it's 120, over square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. Now remember, because they're square roots, this is positive or negative. Still not quite done. I'm going to give you a little word of advice. Go ahead and simplify 120. So 120 can be broken down into 2 and 60, 2 and 30, 2 and 15, 3 and 5. So my simplified form, there's my pairs. The simplified form of this would be x minus 2 equals the positive or negative 2 on the square root of 30 all over 3. So this right here is just the simplified form of this. So yes, that was a lot of work. And there's not a lot of those, but you just need to make sure you understand it. However, we're not completely finished because we have a minus 2. So if we need to still get x by itself, we would need to add 2. And you're going to add 2 and you're going to add 2. And for space purposes, I'm going to have to move up here. So what you're going to get is you're going to get x equals, 2 plus or minus the square root of 30 all over 3. Okay, you might be looking at that and going, oop, I forgot my 2. You might be looking at that and wondering, why did I write it in this form? And down here I have the 2 at the end. You're going to find out in this next section in 1.6 about complex numbers that there's a form called a plus bi. So an actual number like this is out front. It has to be. If you put the number at the end, you're not wrong. But just remember here that this is actually 2 different answers. So if you were to actually having to get an actual value or solve it, which you will when we do quadratic formula, you would have 2 plus 2 root 30 over 3 and 2 minus 2 root 30 over 3. So 2 solutions, similar to absolute value. All right, let's look at E. Okay, order of operations, you want to eventually get this by itself. The rules are no different than if that was just an x. So what first thing you want to do is you want to add 6 to both sides. So what you're going to get is you're going to get x squared over 25 equals 4. All right. Now, there's actually 2 different ways that you could do this problem. You could go ahead and multiply by 25. Go ahead. It's not a problem. It's going to be really easy. So I'm going to actually split this problem into 2. So I'm going to say, okay, the first way I'm going to do this problem is I'm going to multiply both sides by 25. And what that's going to give me, it's going to give me x squared equals 100. I'm going to take the square root of both sides, and that's going to give me x equals positive or negative 10. Beautiful. Or if you notice and you're comfortable with your square roots, you'll notice that this is a perfect square and that's a perfect square. So you could actually take the square root of both sides at this point if you wanted to, because you would square root sides, and what you would get is you would get the square root of x squared is x, the square root of 25 is 5, equals the square root of 4, which is positive or negative 2. Then you would multiply both sides times 5, and your resulting answer would still be x equals positive or negative 10. So 2 different processes, 2 different ways to do it. However, you're still going to get the same answer. Sometimes for those of you who aren't the best when it comes to math, you might want to stick with the more simple way. All right, the next one is going to be the your turn problems that you need to work on. So go ahead and turn your page over. You're going to do the 6z squared equals 150. So make sure that you go ahead and work that out. Pause the video. And when you pause the video, when you're done working it out, go ahead and play it. Okay, pause the video. All right, here's the solution. First thing you wanted to do was divide both sides by 6. So when you got that, you got z squared equals 25. Take the square root of both sides, and that's going to give you z equals positive or negative 5. Okay, pause the video again. Do number 2. All right, now we're going to go over here. With this one, you had to move, so you're going to add 10 to both sides, giving you 7r squared equals 35 over 7. Leaves you, then you're going to square root both sides. Your resulting answer is r squared equals the square, or excuse me, r equals positive or negative square roots of 5. Now, this is the first one I've even mentioned changing to a decimal. Just wanted to take a moment and let you figure that out. So all you would do in your calculators, you would find the square root of 5 and you get 2.23. But I cannot reiterate to you guys enough how important it is to know that the answer is a positive or negative. There are 2 solutions. Okay, go ahead and do number 3. Pause the video. All right, on this one, you're going to divide both sides by 4, and that's going to leave you with x minus 2 all squared equals 2. Then you're going to square root both sides, and that's going to leave you with x minus 1 equals the positive or negative square root of 2. Then you're going to add 1 to both sides, and because this is outside a radical and this is inside a radical, they can't combine. So you want to put the real number out front, which would be 1 plus or minus the square root of 2, and that's your final answer. Go ahead and do number 4. Pause the video. All right, last one. On this one, you would have to subtract 8 from both sides, which would give you x squared divided by 20 equals 7. Then you're going to multiply both sides by 20, and that's going to give you x squared equals 140. You're going to take the square root of both sides. Now, 140 wasn't a square root, so yes, you could have gone in your calculator and gotten a decimal, but I told you at the beginning of the lesson that it needs to be in simplified radical form. So, 2 times, I broke this down, 2 times 70, 2 times 35, so when it was all said and done, 2 had a pair, the 5 and the 7 didn't. So it left you with, oh, did anybody notice? I have to do a positive or negative. So it's positive or negative 2 on the square root of 35, and that's your final answer. Okay, make sure you bring these notes to class tomorrow so that you are able to go over them. I'm willing to help you. Remember, your notes are just the lesson video is just a little introduction to what we'll do. Is the best way for you to learn how to do it is actually apply what you've learned. So when you come into class tomorrow, if you do have your notes done, I will be happy to help you and we'll work these out together. All right, thanks.